Welcome to the fourth video! For some of you, that's your first contribution to the class. Okay, this video is the point after the equivalence point. This is the last, and this is the easiest scenario. So, yay. That's awesome. I'm just so excited about the easiest scenario. It's almost like my brain is tired from having taken all these AP tests. All right. What's that? Taking it one too far? All right. So, all right, let's stop the cat calls. You're creeping people out. The internets are like, what's going on? All right. So, weak acid and his bow, which, all right, weak acid and the bow make some water, make some ions, make some more ions. Again, these guys are aqueous, so they're not really attached to each other. They're separated. In previous examples, we said there's a before moles, a change in moles, and after the moles. And this is the fun point. This is after the equivalence point. And some weird things happen after the equivalence point. Let's review for 2 seconds. How many moles did we start off with of HA? 10. In the previous video, the equivalence point, we had 10 and 10. Now it's time to go a step further. Let's go 10 and 15. Wow, you just don't mess around. Right to 15. I would have said 11. Let's just do 11, okay? Because it's already going to be interesting enough. Crazy man over there in the muscle t-shirt. And yeah. Most people don't wear those fishnet shirts to school, but that's interesting. So, what do we have a limited supply of? The weak acid or the strong base? We're actually going to run out of the acid. So therefore, we have 0 acid left over. We have 1 mole of our strong base left over. And these things really don't matter. We're still going to go, oh, look at that's exciting. And then we're gaining 10. Yay, whoop-de-doo. We just gained 10 of these. But this is the conjugate base, right? This is the strong base. Which matters more? No, they don't all matter equally. This isn't like real world. This is chemistry. Some things are more important in chemistry than others. The strong base is far more important than the weak base. So, you okay? She's having a spasm of some sort. She might be laughing. Okay. So, now, we have 1 mole of this BOH left over, which is going to give away all of its hydroxide. You might hear the talking in the background. That's one of your students disrespecting your education. So what volume did we divide this by last time? 0.51? So the volume needs to be slightly larger because we've added slightly more. So let's go 0.52. I like that suggestion from the girl in the glasses. So we have moles per... It's a pretty common theme, right? Where are your glasses? Don't you have glasses? You broke your glasses. Oh, you're wearing your contacts. That's perfectly acceptable. Contacts. So, this is much more interesting. If this is a strong base, how much of this is left over in the equilibrium expression? None. It all shifts. So all of this shifts, and that's how much hydroxide we have. We don't have to go into ice table land. We don't have to do any of that other nonsense. We can take the negative log of that value, and we'll go immediately to the POH. This is much faster than the previous two because strong bases react 100%. So I'm taking this when simplified down is 1.92, and then I took the negative log of that, and I got negative 0.283. Holy cow, This is a POH. This is a POH. So the pH would be 14.28. Because you do 14 minus a negative and you get, this is a really high pH. It is possible to have a pH above 14. That's just the boundaries based on the pH scale, which is an artificially created scale. So we have gotten to that point. Let's just draw this thing again. So we're like, whoa, whoa, right? So where are we right now? We're up here. So we were at the equivalence point, right? And that was like at 60. And then halfway, the midpoint was at 30. And now we are another little bit past it, and the pH is soundly up here in the 14 land. It's an insane location, right? So these after the equivalence point questions are pretty easy because you have leftover strong base, so it's real fast to get the POH. So I had a question from my very fit student over here who asked me about, what about the reverse scenario? Let's reverse this scenario. If you had just draw this kind of on top of this one, you could have the weak base, the midpoint of the weak base, the equivalence point, and then the strong acid afterwards. Again, you would have strong acid and the weak base would all be used up. You'd have a little bit of strong acid left over. You could take the negative log of that and hop right into the pH. It'd be the same type of question, but in reverse. And I apologize for this little wonk there. That should have been a straight line, not some sort of weird curve. All right, that covers all 4 major scenarios in acids and bases. Thus endeth the 4th video.